Hello, geometry students. We are entering into chapter 10, and right now we are in section 10-1. We're going to talk about the area of triangles and parallelograms in this section. And what I'd like for you to do by the end of this lesson is to be able to calculate the area of triangles and parallelograms in different orientations. So, first of all, what is area and what is perimeter? Because we're going to be calculating both of those today. Area is the space that a shape takes up. So area is the space that a shape takes up. While perimeter is going to be the distance around a shape. So our units are going to look a little different based off of what we're talking about. And I know that you've heard those definitions before, but it's always good to just have a quick refresher. So now we're going to just have our formulas, like what are the actual formulas. So the formula for a rectangle, we oftentimes say length times width. You can say that, but you can also say just base times height as well. So I'm going to give you the formulas for the areas of all of these. So area is going to equal base times height. The perimeter is just going to be all the sides added up. So you might want to say 2 of the base and 2 of the height or something like that. But perimeter in general is all sides added up. So I think I'll actually put that up here. So I'll just say to calculate add all sides together. Okay. Now the area of a parallelogram is actually going to be exactly the same. We're going to say area is equal to base times height again. Triangle is where it gets a little different, and the formula for the area of a triangle is 1/2 base times height. I'm sure you've heard of these 3 formulas before, but once again, we're just refreshing them. So now we're going to start using that information to start making some calculations. I'm not going to do every example in the notes because tomorrow we'll do some examples in class. So I'm going to do this example A today in the video. It says find the area and perimeter of the parallelogram. Well, we definitely have enough information to find the area, so let's do that first. So I'm going to say area is equal to base times height. I'm just using that from my formula up here. Now, base is going to be the flat part that the shape is resting on. So 15, and we know based off of the definition of a parallelogram, opposite sides have to be congruent. So if this side is 15, then this side down here is 15. So we have area is equal to 15 times height must be perpendicular to the base. So notice how we have this 90-degree symbol right here. That means that this 8 is perpendicular. So we have 15 times 8. Now you're ready to just put that into your calculator, and you're going to get 120 for that. So we have area is equal to 120. Now, I'm going to put my unit on there. We're working in inches, so I'm going to say inches, but 120 inches is a distance. We need something that describes space that's being occupied. So we're going to say square inches by doing it like that. It is not the 120 that's being squared, it's the unit, the inches, that's being squared. So our area is right here. Now, we won't be able to find the perimeter with the information we're given, so I'm going to actually add a piece of information on this example just so we have it and we can do that. Let's say that from here to here is 6. Okay, so now we can easily figure out the distance around. So we know, okay, this part is 15 and the bottom part is 15, but we need to figure out this length right here. Well, this is a right triangle, so we can use the Pythagorean theorem to figure out what the hypotenuse is. So I'm going to say 6 squared plus 8 squared is equal to c squared. That's 36 plus 64 is equal to c squared. That adds up to 100. Then we square root both sides, and I'm getting 10 is equal to c. So now I know that this side is equal to 10, and I'm just saying, that's because of this number that I chose here. If I would have chosen a different number, it would have resulted in something different, but I just wanted to put in another piece of information so that we could solve this. So now I know that this side is 10, and this side is 10. So to find your perimeter, you're adding up all the sides together. So we have 10 plus 15, the top side, plus 10, which is going to be the right side, and then plus 15, the bottom side as well. Now you might be thinking, what about that 6? Well, this 6 is part of the 15. So from here to here, would it be 9? So I'm going to just say plus 15 again. And let's add these up. 15 and 15 is 30, plus 20 is 50. So the perimeter is 50 inches. We'll do this one tomorrow in class. So now flip your page over, and we are on example 2 now. So example 2 says find the area and perimeter of the triangle. So remember, area is going to equal, for a triangle, 1/2 base times height. So area is equal to 1/2 base times height. Now the base has to be what the triangle is like sitting on, while the height must be at a 90-degree angle from the base. So I'm actually going to put a note of that up here in the corner because that's really important. Height must be 90 degrees to the base. It has to be. If it is at an angle, then your height is going to be all mixed up. So I'm probably going to be saying that a lot in class, just to remind you guys. Height must be perpendicular to the base or 90 degrees to the base, essentially the same thing. So what you are allowed to do is to redraw this so that the base, so it's in a different orientation. So I'm going to kind of rotate this similar to what we did in our last unit. So I'm just going to draw this triangle in this orientation now, to where this corner has gotten spun down here. So I have 4.5 yards down here, and then I have 6 yards up there. So now it'll be a lot easier for me to see my base and my height. So let's plug these values into our base and height. So I'm going to say area is equal to 1/2 of 4.5 times 6. When I put all of that into our calculator, I am going to get 13.5, I believe, but I'm going to double check just in case. So I'm taking 3 times 4.5. Yes. Okay, so area is equal to 13.5, but 13.5 what? So we're working in yards. That's the unit that we have. Because it's area, I'm going to square the unit because that's signifying that it's taking up space. Now we need to figure out the perimeter. To figure out the perimeter, well, this is once again a right triangle, so we can use the Pythagorean theorem. We need to figure out the long side. The hypotenuse is always opposite the 90-degree angle, so that's how I know it's the long side. So let's just do that. I'm going to say 4.5 squared plus 6 squared is equal to c squared. When I square both of those, 4.5 times 4.5 is 20.25. Plus 36 is equal to c squared. When I add those up, I get 56.25 is equal to c squared. And when I square root both of those, I end up getting 7.5 is equal to c. Now you are not done. What we've just found is that this section right here is 7.5 yards, or you could label it on your other triangle, this one, 7.5 yards. So to find the perimeter is not only one side, the perimeter is all 3 sides. So I'm now going to take that value and plug it in with these others to calculate the perimeter. So I'm going to say perimeter is equal to 4.5 plus 6 plus 7.5. And when I add all of those up, that's going to get me 11 12, 18. The perimeter is going to be 18 yards. All righty. Moving on to example 3. Here we just have word problems. Make sure you're just taking it one piece at a time and always start with what you know. Starting with what you know is going to be one of the strongest ways for you to get a problem up and going. So this says a parallelogram has area equal to 60 meters squared and a base of 12. What is the height of the parallelogram? So right now we automatically know we're talking about a parallelogram, and the area or the formula for the area of a parallelogram is right here. It's base times height. So I'm going to write that formula down so that we have it. I'm going to say area is equal to, oh, I almost wrote the wrong thing, base times height. Area is equal to base times height. Now, we were actually told two pieces of information. It says the area is 60 meters squared. I don't need to worry about the unit right now. Let's just use the number. So I'm going to put the 60 in for the area. So I have 60 is equal to, and then it says that a base is equal to 12. So instead of writing B, I'm going to put 12 in there. But the question is, what is the height? So I don't know the height. That's my variable. So 60 is equal to 12h. Solve for h, and then you're good to go. So let's divide by 12 on both sides. And that's going to get me 5 is equal to h. I'm going to go ahead and put the units on here. So I'm going to say height is 5 meters. Just so it can be very specific for your notes. Example B, we're going to do in class. So transition to page 5 in your packet. And we're going to work just a couple examples on this page, and then we will be good to go. So this one says, for example 4, we're just finding some areas of some more complex shapes. It says find the area of and the perimeter of the rhombus. All right. There is another way to find the area of a rhombus, but today I'm going to show you one method, and then tomorrow I'll show you another method. So just one piece at a time. So let's find just some missing pieces to this first. This is a rhombus, so we know that all 4 sides have to be the same length. So I'm going to put some congruency markers on there so we can remember that. We also know that there is a 90-degree angle right here because the diagonals are perpendicular. So I'm going to put in that perpendicular symbol right there. Now finally, I also know that all 4 of these triangles are the same size. So I know this triangle is the same as this triangle, which is the same as that one, which is the same as that one. So what I can theoretically do is, okay, if I can figure out one triangle, then I can multiply that by 4 to get the total. So for this strategy, and like I said, I'm going to teach you another strategy later on, but for this one, we are going to add the areas of the 4 triangles. That's how we're going to figure out the total area. So we're going to need some more information. I am going to pull this triangle out to the side, and we're going to start labeling some stuff on it. So I know that this length right here is 4, and I know that this degree is 60, and this degree is 30. This is a special right triangle. So if we need to, we can draw our reference triangle over here to the side and set up our proportions. So if this is 60 and this is 30, this would be 1, square root 3, and 2. So I'm going to try to figure out what the value of x is and what the value of y is. I just need to know how tall it is and how long the hypotenuse is. So I just put x and y in there just so we could have some variables to solve for. So when we have similar right triangles, we have to set up proportions and then cross multiply. So I'm going to say 4 over 1 is equal to x over square root 3. So we have 4 over 1 is equal to x over square root 3. When we cross multiply, I get x is equal to 4 square root 3. So that's helpful. It's not our answer yet, but it is helpful. So I'm just going to kind of underline that in a way so that we can reference it later on. Now let's find the length of this. So, oh, and I'll go ahead and actually put that 4 square root 3 up here in this image. So we've got 4 square root 3. Okay. Now let's figure out what y is equal to. So I'm going to say 4 over 1 is equal to y over 2. So 4 over 1 is equal to y over 2. We cross multiply, and I get y is equal to 8. Awesome. That's another very valuable piece of information. It is not the answer per se, but it is useful to getting us to the answer. So I marked that on the rhombus as well. Now we have enough information and we can calculate the perimeter and the area of the rhombus. To calculate the area again, I'm going to take this triangle plus this triangle plus this one plus this one. But remember, all 4 are the same. So if I can figure out the area of this top left one, then I can figure out the area of all of them. So I will draw that one more time just so we have it. We have 4 square root 3, and 8. We want to find the area of this. So the area is going to equal 1/2 base times height. Well, the base is 4 and the height is 4 square root 3. So the area is going to equal 1/2 times 4 square root 3. Well, when I multiply all of these out, I'm just going to be getting 8 square root 3. 1/2 times 4 is 2, and 2 times 4 is 8. So 8 square root 3 for our area, and we're going to end there with that part. Whoa, except we're not. That's the area of just one triangle. So now I need to take that and add it up to itself 4 times, or just multiply it by 4. My apologies. So this is not our answer. So I'm now going to take 8 square root 3 and multiply it by 4. And that is going to get me 32 square root 3 is equal to the area. This guy right here is our answer. Let me block that in so you can see that. Sorry, I almost didn't finish that problem. Okay, now let's find perimeter. Perimeter is going to be a lot quicker. Perimeter is going to equal all 4 sides added up. So if this side is 8, but this side has to be the same length, and that one's also 8, and this one's 8, and that one's 8. So 8 plus 8 plus 8 plus 8, that is getting us 32, and I'll put the M on there for meters. So now we have our area and our perimeter. I'll highlight that one too, just for consistency's sake. We'll do this kite example in class tomorrow, but we are going to jump down here and do this example with finding the value of h given that the solid figure is a parallelogram. So what's going on in this image is they are changing the orientation of the parallelogram. They're saying, okay, in this orientation, the base is 18 and the height is 10. But what would happen if we changed it to where it was drawn like that? What would happen then? And that was a very poor drawing, so let me try it one more time. So basically, I'm taking that image and I'm spinning it around, and they're saying, okay, if this is 12, how tall is it? So what we're going to need to do, we're going to need to figure out the area first and then plug in new values. So step 1, find the area. Well, we know the formula for the area of a parallelogram is base times height. So area is going to equal base times height, And based off of this information, the base is 18 because we know opposite sides of a parallelogram are congruent. So I'm going to say 18. So 18 times the height, which is 10, area is equal to 180. Awesome. That's not what it asks us for, though. It asks us for the value of h. So what would the height need to be if we turned it around? So now that we've spun it around, it's in this orientation. Now you might be thinking, where did I get that 12? Well, I got that 12 from this. So what I'm going to do, I'm going to take this 12 and I'm going to put it in for the base value now. I know the area has to stay consistent. If I spin a shape, its value or the space that it takes up does not change. Its area remains constant. So step 2, substitute in your new values. So I'm going to say once again, area is equal to base times height. Well, I know my area is 180 now, and my new base is 12. Let's figure out the height. Divide both sides by 12, and when I do that, I'm getting 15. So 15 is equal to the height on this one. All right, that is all for today's notes. We will pick up on this the next time we are in class together. If you have questions, make sure to ask them, and I hope you have a great night.